The International Space Station took over a decade to complete. We've got to remember, the station isn't just aimlessly floating in space. It's going incredibly fast, about 20 times the speed of sound here on Earth. It orbits the Earth once every 90 minutes. Here's the front of the station. It always travels in this direction. So this is forward and aft, port and starboard, and then there's zenith pointing away from the Earth and nadir pointing towards the Earth. These terms are part of the regular vocabulary of an astronaut. We'll be using them a little bit throughout this video. This is what the completed station looks like. The only part that the astronauts can live in are the pressurized modules. When I say module, I'm referring to one of these cylindrical pieces of the space station. It has air to breathe, comfortable living conditions, and protects the astronauts from the vacuum of space. Each module has one or more berthing ports that can be connected to other parts of the station. Sometimes these are referred to as docking ports, but if we're being specific, it is a berthing port because the joining module or spacecraft must be assisted by use of a robotic arm. There are two main sections to the station. The Russian orbital segment, these are modules from Russia, and the United States orbital segment. These are modules from the United States, Europe, and Japan. You can see how the modules on each side look just a little bit different. On the US side, the modules are connected by the Common Berthing Mechanism, or CBM for short. There are two different sides to this, the active side and the passive side. Once these are brought together, latches pull them in close, and then there are 16 bolts to firmly mate them together. The space in between is called the vestibule. This will be pressurized with air. This process takes a few hours. Then the hatch is opened, some of the hardware is removed, and connections are made in between the modules, which includes oxygen, power, data, and water. Once finalized, there is a white protective barrier put in place. The astronauts can now move freely in between the modules. The Common Berthing Mechanism is used for modules that are permanently attached together, like the Harmony and Destiny modules. They can also be used for visiting spacecraft such as the SpaceX Cargo Dragon. The Russian side of the station uses a different docking mechanism that is not compatible with CBM. We need some way to connect to the different mechanisms. This is kind of like taking a power plug from the United States and bringing it over to Europe. It's not compatible with the wall plug. What do we need? An adapter. It's the same concept on the space station, but on a larger scale. Two different mechanisms, so we need an adapter in between. This is called the Pressurized Mating Adapter, or PMA for short. The larger side uses CBM, which can be attached to the US side of the station. The smaller side uses APAS. This is compatible with the Russian side of the station and with the space shuttle. On the station today, there are 3 of these adapters. PMA-1 is permanently in place, connecting the two sides of the station. PMA-2 and PMA-3 were used as docking ports for the space shuttle. The smaller side, which is the side that uses APAS, was used for the space shuttle. This is how it would dock to the space station. Both of these PMAs now have yet another type of adapter placed at the end. This allows for more modern spacecraft to dock to the space station. Now let's take a quick look at the space shuttle. The crew spends most of their time up here in the crew compartment. Back here is the payload bay. This is where the space station modules were carried up into space. Up front here is the orbital docking system. This is the place that could dock to the International Space Station. The astronauts can also do spacewalks from out of this hatch. On the side here is the Canadarm. It's a robotic arm that is capable of moving things around in space. The arm can be controlled from inside of the space shuttle at this workstation. The space shuttle launches took place from Kennedy Space Center in Florida. Once in space, the payload bay doors were opened. They remained open for the entire time they were in space. Then it took a few days for the space shuttle to catch up with the ISS. The space shuttle is retired now, but it played a crucial role in building the space station. Let's take a look at a few of these space shuttle missions. This first mission we'll go over in a bit more detail. I want to give an idea for the timeline and how long things took. And then for the next 3 missions, we'll go over just a little bit quicker once we get the right idea. The first mission we'll talk about is STS-88 in December of 1998. And the STS stands for Space Transportation System. All shuttle missions started with these 3 letters. This was the first shuttle mission to the International Space Station. At this time, the station had only one piece. It was the Russian module Zarya orbiting the Earth all by itself. On the completed station, this is where Zarya is. And this first shuttle mission brought up the Unity module. This is kind of like the center hub of the station, with 6 berthing ports where other modules can be attached. Unity was launched with PMA-1 and PMA-2 already attached to it. This mission took almost 12 days to complete. The first few days were used to make preparations and to catch up to Zarya. On day 3 of the mission, the Canadarm was put to work. It was time to lift Unity out of the payload bay. PMA-2 was then attached to the orbital docking system on the shuttle. The Canadarm can move large masses in space due to being weightless while in orbit. It had to move very slowly to not strain the robotic joints. It took hours to complete and very careful movement. The shuttle's thrusters were fired to bring the modules together. On the 4th day of the mission, the space shuttle slowly approached Zarya. The Canadarm grabbed onto it and then moved it into position above PMA-1. Again, the shuttle's thrusters were fired to bring the modules together. It took a few more days of preparation before they could go inside the station. There were 2 EVAs where they get into their spacesuit and go outside the station. They connected cables and installed antennas on the outside of the station. The Canadarm was used to help move the astronauts around. On the 8th day of the mission, they opened the hatch and entered the station for the first time. They only stayed inside for about a day, just enough to check things out and prepare it for the next mission. On the 10th day of the mission, there was 1 more EVA to finish the installation. Then on the 11th day of the mission, the shuttle undocked from the ISS. At this point, there was no permanent crew yet. The station was too small. Unity and Zarya orbited all by themselves for the next few months. Of course, all while being monitored by Mission Control back on Earth. So we'll fast forward just a few years in time. The station had a few more modules, and there were 3 crew members living on board the station. The next mission we'll talk about is STS-98 in February of 2001. So here's our completed station. Here's what it looked like right before STS-98. This mission brought up the Destiny module. STS-98 lasted for 13 days. But they were attached to the station for only 6 of those days. They docked to PMA-3 on the nadir or bottom side of the station. The Canadarm was used to grab onto PMA-2 and relocate it to the side of the Z1 truss. Then the arm was used to lift the Destiny module out of the payload bay, slowly flip it 180 degrees, and then attach it to the forward berthing port on Unity. This took hours to complete and very careful movement to make sure nothing was damaged. The next day, they opened the hatches and went inside Destiny for the first time. The US laboratory is mainly used for scientific research on board the station. PMA-2 was then relocated to the forward side of Destiny. The mission had 3 separate EVAs to connect and install items on the outside of the station. The purpose of this next mission was to give the station its own robotic arm, called the Canadarm2. The first Canadarm was on the space shuttle. Very useful, but it was permanently attached to the shuttle. This means it goes home at the end of a shuttle mission. The Canadarm2 can lift heavier loads and would now stay on board the station, so it can be used in between shuttle missions. Here's an example of where you might find the Canadarm2 on the station today. The arm can attach to the station at either end. These are called latching end effectors. It attaches to anywhere on the station that has a power data grapple fixture. As you might guess, it provides power and data connection so it can be controlled from inside the station and from mission control back on Earth if needed. These power data grapple fixtures are in many places on the outside of the station. The mission that brought up the Canadarm2 was called STS-100. It was a 12-day mission. The shuttle docked to the front of the station at PMA-2. This carried Raffaello, a multi-purpose logistics module which would be temporarily attached to the station. The second piece of cargo was the Canadarm2. It was brought to the station on board a special pallet. The shuttle's Canadarm grabbed onto the pallet and lifted it out of the payload bay, and then attached the pallet to the top of the Destiny module. It was slowly unfolded and put together by the astronauts. They also had a little help from the shuttle's Canadarm. Then the Canadarm2 was moved on its own for the first time. It was initially connected to the side of the Destiny module. At the end of the mission, the Canadarm2 was used to lift the pallet and hand it over to the shuttle's Canadarm. This was the first robotic handshake in space, sometimes referred to as the Canadian handshake, because both of these arms were built by Canada. The empty pallet was then put back into the payload bay. A few days later, the shuttle undocked from the station. The Canadarm2 was essential for constructing the rest of the space station. The last mission that I want to show in this video is STS-104. So here's the completed station, and here's what it looked like right before STS-104. This mission brought up the Quest airlock. The mission lasted for almost 13 days, once again docking to the front of the station at PMA-2. This was the first time they used the Canadarm2 to help construct the station. The Quest airlock was slowly moved into position on the starboard side of the Unity module. Two of the astronauts were in position, ready to help install the new module. Once Quest was installed, it was time for the high-pressure gas tanks. Once again, the Canadarm2 was used to move the tanks around. The astronauts helped guide the tanks into position. Up until this point, they could only perform spacewalks from the shuttle's payload bay. But the Quest airlock gave them another option. This part is called the equipment lock, and this part is called the crew lock. Once the astronauts are inside of their spacesuits, the hatch is closed and the crew lock is depressurized. This means that all the air is pumped out. Now the airlock hatch is opened, and then the thermal cover on the outside. The opening points straight down, so the first thing they see is the Earth right beneath them.